Welcome back. We're going to discuss Lesson 4:1, types of lines, planes, and angles formed by parallel lines cut by a transversal. Parallel lines are lines that don't intersect and at the same time are on the same plane. Let's take a look at the cube to the right. Lines L and M are lines that don't intersect, but at the same time, they are on the same plane. This is a plane, and it's one of the planes of this entire cube. Note, to indicate to the reader that the lines are parallel, we use these arrows or feathers to show that these lines are parallel. So over here, what I'm going to do is draw two lines. And these two lines don't intersect. To show that these two lines are parallel, what I need to do is draw these arrows. One arrow here and one arrow there. This is to tell someone that those two lines are parallel. Now, if you have another set of parallel lines, then you need to draw two arrows instead of one. So we know that these two lines are parallel. And what I have over here are two lines that are parallel to each other. So, in order for me to show the reader that those two lines are parallel, I need to draw my arrows. So I need to draw how many arrows this time? Two arrows this time. We know that these two sets of parallel lines have different slopes. If I use one arrow here, one arrow there, and one arrow here and one arrow there, that's not true because, again, they have different slopes. So I need to differentiate them. So I need to draw an arrow here and arrow there to show that those lines are parallel. And I need to use two arrows here and two arrows there to show that those two lines are parallel to each other, but not parallel to these lines. Hopefully that makes sense. Perpendicular lines are lines that intersect at right angles. We know if you have two lines that are perpendicular to each other, they intersect at a 90-degree angle. And we use that square to show that those two lines are perpendicular to each other. If we look carefully, we can see that line K and line L are perpendicular to each other because of this square. It tells us they intersect at a 90-degree angle. Skew lines are lines that don't intersect and are on different planes. So here's an example of skew lines. First off, I want to take a look at these two planes here. This plane and this plane. We know just by looking at the speech bubble here, K and M are skew lines. Line K is exclusive to the front plane, and line M is part of the plane on the right and on the back. However, we can see that these two lines will not touch each other. They are lines that don't intersect and are on different planes. Here's another example of skew lines. Let's take a look at the top plane and the front plane. I'm going to draw a line here and a line there. Note that these two lines don't intersect, but they are on different planes. So they are not parallel lines, they are skew lines. Parallel planes are planes that do not intersect. For example, the top and bottom of the cube represent parallel planes. So if we look at this cube here, This plane and this plane are parallel planes. The plane on the left and the plane on the right are also parallel planes. Parallel planes are just like parallel lines, except you're dealing with planes this time. Let's take a look at some examples here. Use the figure for exercises 1 to 3. Identify each of the following. Note that we have plane W right here. Number 1, let's go ahead and find an example of a pair of parallel lines. I can see that line G and line H are parallel because of these arrows. One arrow here and one arrow there. These two lines don't intersect and at the same time are on plane W. So we know for sure that those two lines are parallel. So I'm going to write line G is parallel to line H. Okay, so I'm going to go ahead and move on to number 3 and then do number 2. Number 3, a pair of perpendicular lines. If we look, we can see that line G and line J intersect at a 90-degree angle. So those two lines are perpendicular to each other. So I'm going to write line G is perpendicular to line J. Number 2, a pair of skew lines. So remember, skew lines are lines that don't intersect and are on different planes. I'm going to say that line H and line J are skew lines. Line H is part of plane W, and line J, the only part of line J that's on plane W is this point. This is not on plane W. Only this point is. Line J has its own plane. So these two lines don't intersect, but are on different planes. Lines H and J are skew. Okay, moving on. Use the next figure for exercise 4 to identify the following. We're going to identify a pair of parallel planes. Now remember, parallel planes are planes that do not intersect. To name a plane, you need to have 3 points. So we can look at the front plane and also the back plane. Those two planes are parallel to each other. The front plane contains points D, E, F, and the plane in the back contains points G, H, and J. So plane DEF is parallel to plane GHJ. Now let's review what we know about angles. We have two lines that intersect and form an X, and given the fact that measure angle FEB is 60 degrees. This is angle FEB, and that angle is 60 degrees long. And if this angle is 60 degrees, then we know that the measure angle HEG is also 60 degrees because vertical angles. So the measure angle FEB is 60 degrees, and that's a given. The measure angle HEG is 60 degrees as well, because of vertical angles. Now we need to figure out how long the measure angle HEF and measure angle BEG are. We can see that this forms a linear pair. If this is 60 degrees, then this must be 120 degrees. Because remember, linear pair, the two angles add up to 180 degrees, and they are stuck together. So if this is 60 degrees, then the measure angle HEF is 120 degrees. And by vertical angles, you can say the measure angle GEB is 120 degrees because the angle across from it is also 120 degrees. So I can write measure angle GEB is 120 degrees by the vertical angles theorem. You can also say the measure angle GEB is 120 degrees by the linear pair theorem if you would like to go that route. Now let's see what happens when we have two parallel lines cut by another line called a transversal. I know that we have a picture already drawn out for us, but what I want you to do is I want you to trace over these lines. I want you to build muscle memory. So I'm going to draw two lines that are parallel to each other. And remember, to show that these two lines are parallel, we need to draw those arrows. So one arrow here and one arrow there. Then I'm going to introduce you to the line that cuts, aka the transversal. This line here is the transversal, which will cut the parallel lines. So let's make a note here. The line that cuts the parallel lines is what we call the transversal. Now observe, we have these two lines that are parallel to each other, cut by a transversal. What is the result of having parallel lines cut by a transversal? They create angles. We have an angle here, an angle here, angle there, 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 and there. So how many angles do we have? We have 1, 2, 3, 4, 5, 6, 7, 8 angles. Now with parallel lines cut by a transversal, we can see how angles relate to each other. Are they congruent? Are they supplementary? Those are the things that I want you to take note of. Now, let's take a look at this region and compare that to this region. This region contains angles 1, 2, 3, and 4, and this region over here contains angles 5, 6, 7, and 8. Now compare angles 1 and 5. We can see that angle 1 is on the top left of this region, and angle 5 is on the top left of that region. So what can we say about angles 1 and 5? We call those angles corresponding angles. Now, corresponding angles are located on the same side of the transversal, but are on different lines. So we can see that this angle is part of this line, and this angle is part of that line, but these two angles are on the same side in the same place, but in different regions. Corresponding angles are congruent. Now let's write this down. Corresponding angles. We're going to list out all the corresponding angles that we see. We know that angles 1 and 5 are corresponding therefore congruent. We can also say the same thing for angles 2 and 6. Angles 2 and 6 are on the same side of the transversal, and they are located on the top right of their regions. So angle 2 is congruent to angle 6 by corresponding angles. We can see that angles 3 and 7 are on the same side of the transversal, and they are located on the bottom left of their regions, so they are congruent to each other. And our last pair would be angles 4 and 8. They are on the same side of the transversal, and they're located on the bottom right of their regions. Now, if you're having troubles understanding what corresponding angles are, let me go ahead and give you an example. Imagine that we have two universes. This is universe 1, and this is universe 2. You're in universe 1. And let's say that you're standing right here in universe 1. If you're standing right here where angle 1 is located, it's kind of like saying that you're standing right here where angle 5 is located, but angle 5 is located in universe 2. So, we say that these two locations correspond to each other. So angles 1 and 5 are congruent by corresponding angles. Now I want to go ahead and move on to other types of angles formed by parallel lines cut by a transversal. While I was discussing corresponding angles, I mentioned the words same side of the transversal. We can see that angles 1, 3, 5, and 7 are on the left-hand side of the transversal, and angles 2, 4, 6, and 8 are on the right-hand side of the transversal. While angles can be on the same side of the transversal, angles can be on opposite sides of the transversal. For instance, angles 1 and 2, they are not on the same side of the transversal, they are on opposite sides of the transversal. Angles 3 and 4 are on opposite sides of the transversal, angles 5 and 6 are on opposite sides of the transversal, and angles 7 and 8 are on opposite sides of the transversal. Now, what about angles 2 and 7? Are they on the same side of the transversal, or are they on opposite sides of the transversal? Well, 2 is on the right-hand side, and 7 is on the left-hand side of the transversal. We can say that those two angles are on opposite sides of the transversal. Now, when I say two angles are on opposite sides of the transversal, they are alternate, the official word that I will be using for our notes. Okay, on my paper, I'm going to write same side, and then I'm going to write alternate twice. So alternate here, and alternate there. Now notice the parallel lines that we drew. I want you to understand that 1, 2, 7, and 8 are outside of the parallel lines. Those angles are what we call exterior angles. Because again, they are outside of the parallel lines. What is the synonym for outside? That would be exterior. So angles 1, 2, 7, and 8 are exterior angles. But what about angles 3, 4, 5, and 6? Well, those angles are inside of the parallel lines, so they are called interior angles. Now look at angles 3 and 5 specifically. Are they on the same side of the transversal, or are they on alternate sides of the transversal? The answer to that question is they are on the same side. Now, are these two angles on the interior or exterior? These angles are inside of the parallel lines, so therefore they are interior angles. So what I'm going to write over here, I'm going to write same side interior angles. Now, same side interior angles are angles that are supplementary to each other. We can see that 3 and 5 are same side interior angles, so those angles add up to 180 degrees. Now I'm going to go ahead and make a note here. Same side interior angles are supplementary. And again, supplementary angles are two angles that add up to 180 degrees. So we can go ahead and make a note that angles 3 and 5 are supplementary. And we can also say the same thing for angles 4 and 6. They are supplementary. Why can I say angles 4 and 6 are supplementary? Well, they are angles that are on the same side of the transversal and also on the interior of the parallel lines. So remember, same side interior angles are supplementary. So we are done with same side interior angles. We are not going to discuss same side exterior angles because we can figure out those angles by using other theorems. So we're going to go ahead and move on to alternate interior and exterior angles. Now we're going to look at alternate interior angles. Alternate interior angles are two angles that are inside of the parallel lines and on opposite sides of the transversal. Alternate interior angles are congruent. So now we're going to list out all the alternate interior angles. We can see that 3 and 6 are inside of the parallel lines and they are on opposite sides of the transversal. They are alternate. So angles 3 and 6 are congruent by alternate interior angles. We can also say the same thing for angles 4 and 5. Because again, those two angles are inside of the parallel lines and they are on opposite sides of the transversal, or they are alternate. So I will write angle 4 is congruent to angle 5. Now finally, alternate exterior angles. Alternate exterior angles are similar to alternate interior angles. Alternate exterior angles are two angles that are outside of the parallel lines and on opposite sides of the transversal. Alternate exterior angles are congruent as well. So angles 1 and 8 are exterior angles and they are outside of the parallel lines. So we call them alternate exterior angles. So angles 1 and 8 are congruent. We can also say the same thing for angles 2 and 7 because those angles are outside of the parallel lines and they are on opposite sides of the transversal. So again, angles 2 and 8 are congruent. Okay, great. So we just finished this part of the notes. What I want you to do is take out your pink sheet and fill out the first page of the pink sheet. You're going to find the video that is titled Lesson 40 Notes, Pink Sheet Properties, and you're going to fill out the front page only. Once you are done filling out the front page, you're going to go back to this video and continue on with the notes. Welcome back. We're going to identify the following from the figure on the right. Line A is parallel to line B, and yes, I know that this is a typo here. It should have only one R. So here's line A, here's line B. These two lines are parallel to each other because it's stated in the problem itself. So we have parallel lines cut by a transversal. And remember, the transversal is the line that cuts. So when you have parallel lines cut by a transversal, you have angles being formed. So let's take a look at these problems here. Number 5, a pair of corresponding angles. 1 and 3 are corresponding to each other. And if you're having troubles remembering that, well, think universes. We have universe 1 and universe 2. If you're standing in this corner, it's kind of like saying that you're standing in this corner. So angles 1 and 3 are corresponding angles. Number 6, a pair of alternate interior angles. Now, let's go ahead and figure out what the exterior angles are and what the interior angles are. So anything outside of the parallel lines are exterior angles. So these angles are exterior angles. And the angles inside of the parallel lines are interior angles. They are inside of the parallel lines. So let's go ahead and find the interior angles that are on opposite sides of the transversal. And I'm looking at angles 2 and 3. 2 and 3 are inside of the parallel lines, and they are on opposite sides of the transversal. So we can say that 2 and 3, or angles 2 and 3, are alternate interior angles. Number 7, a pair of same side interior angles. So we're going to be looking at interior angles, and they need to be on the same side of the transversal. 2 and 5 are interior angles, and they are on the same side of the transversal. So angles 2 and 5 are same side interior angles. Number 8, a pair of alternate exterior angles. So we need to look at exterior angles, and they need to be on the opposite sides of the transversal. And I want to look at 1 and 4 specifically because these two angles are outside of the parallel lines. They are exterior angles, and they are on opposite sides of the transversal. Now, remember, corresponding angles are congruent. Alternate interior angles are congruent. Same side interior angles are supplementary. And alternate exterior angles are congruent. So let's take a look at what we have here. We can see that corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, but same side interior angles are supplementary. So every type of combination except same side interior angles are congruent. Same side interior angles are supplementary, meaning two angles add up to 180 degrees. So if you're having issues remembering, just know that same side interior angles are the only angles that are supplementary. Same side supplementary. That alliteration will help you remember that those angles, same side interior angles in particular, are supplementary. Okay, we're going to flip the page now. In the figure, measure angle 5 is 72 degrees. Find the measure of each angle. Tell which postulates or theorems you used. You're going to need your pink sheets for these problems. You're going to need the pink sheet for today and the pink sheet that you obtained in Unit 3. So let me go over the question again. You're going to find the measure of each angle. So you're going to find the measure of angle 4 and the measure of angle 2. And once you figure out the measure, you're going to tell me how you got that answer. You're going to tell me which postulate or theorem you use. And that's why you're going to need your pink sheets to do these problems. Okay, so the diagram on the right here, we have parallel lines cut by a transversal. We know that lines N and P are parallel because of these arrows here. And this is the line that cuts, so this is the transversal, which is line T. It says that the measure of angle 5 is 72 degrees, so I'm going to write 72 degrees next to the number 5 right there. So I need to figure out how long angle 4 is. This is where angle 4 is on the diagram. So if I know that the measure of angle 5 is 72 degrees, then the measure of angle 4 must be 72 degrees by corresponding angles. So if you're standing over here, it's kind of like saying you're standing over there. So angle 4 is congruent to angle 5 by corresponding angles. And if the measure of angle 5 is 72 degrees, then that implies that the measure of angle 4 is 72 degrees as well. So you're going to provide the answer, and you're going to give me the reason. And then let's go ahead and figure out the measure of angle 2. This is where angle 2 is located on the diagram. We know that angle 4 and 5 are congruent to each other because of corresponding angles. That's the reason. So they're both 72 degrees. If we look at angle 4 and angle 2, these two angles are congruent to each other by vertical angles. So I can say angle 2 is congruent to angle 4 by vertical angles. And if the measure of angle 4 is 72, then the measure of angle 2 is also 72 degrees. Okay, moving on, in the figure, suppose that measure angle 8 is 105 degrees. Find the measure of each angle. Tell which postulates or theorems you use. So this problem is basically this problem, except that measure angle 8 is 105 degrees, which I will put right here on our diagram. So the measure of angle 8 is 105 degrees. And I want to figure out the measure of angle 1. So here's 8, here's 1. Those two angles are congruent to each other because they are corresponding. So angle 1 is congruent to angle 8 by corresponding angles. And if the measure of angle 8 is 105 degrees, then the measure of angle 1 is also 105 degrees. Okay, so let's move on to 1b. Find the measure of angle 2. Angle 2 is located right here on our diagram. And we're going to need our pink sheets to answer this. We have the measure of angle 1, which is 105 degrees, and the measure of angle 2 is something. That's what we're trying to figure out here. Well, if I look at these two angles, they form a linear pair, meaning these two angles add up to 180 degrees. So in order for me to figure out the measure of angle 2, I can do 180 minus 105, or just do algebra and solve for the measure of angle 2. So I'm going to say 180 minus 105, and 180 minus 105 is 75 degrees. So the measure of angle 2 is 75 degrees. And I'm going to write my answer over here. The measure of angle 2 is 75 degrees. Now, how do I formulate my answer? Well, I say by the linear pair theorem, angle 1 and angle 2 are supplementary. And I'm going to shorten that. And we're going to figure out how long the measure of angle 3 is. This is where angle 3 is located on the diagram. And this one's really easy because we know that the measure of angle 1 is 105 degrees. So that means the measure of angle 3 must be 105 degrees as well, because angles 1 and 3 are congruent by the vertical angles theorem. Let's move on to the algebra side of things. Use the figure at the right to find the indicated variable. Explain your reasoning. Here's our diagram. We have parallel lines cut by a transversal. If the measure of angle 4 is 2x minus 17, so where's angle 4? Angle 4 is located right here, and I'm going to write 2x minus 17 next to it. And the measure of angle 1 is 85 degrees. Our goal here is to find x. So let's take a look at angles 1 and 4. They don't have any sort of relationship to each other. So I need to make sure we get to one of these things here. And how I'm going to do that is this. Note that angle 1 and 3 are congruent by vertical angles. So I'm going to write angle 1 and angle 3 are congruent by vertical angles. So I'm going to write 85 right here, because if this is 85, then angle 3, or the measure of angle 3, is 85 degrees. And now we can look at 3 and 4 here. 3 and 4 are inside of the parallel lines, and they are on the same side of the transversal. So these two angles, angle 3 and angle 4, are supplementary because of same side interior angles. So if these two angles relate to each other by the same side interior angles, then I'm going to say that the measure of angle 3 plus the measure of angle 4 equals 180 degrees. The measure of angle 3 is 85, plus the measure of angle 4 is 2x minus 17. And I'm going to add them up and equal to 180 degrees. We're going to combine the like terms here. I have 85 minus 17, and 85 minus 17 is 68. Plus 2x, equal that to 180 degrees. So that means I'm going to get 2x equals 112 and x equals 56. So this is my answer, and I don't need to do anything else because my goal for this problem is to find x. Okay, so let's take a look at B. It says find y if the measure of angle 3 is 4y plus 30 and the measure of angle 7 is 7y plus 6. Problems A and B do not relate to each other, and here's why. For A, we had the measure of angle 3 be 85, but B says measure angle 3 is 4y plus 30. So we're using the same diagram, but different numbers and variables. So I'm going to use a different color. You should too, so you don't confuse yourself. The measure of angle 3 is 4y plus 30. So I'm going to write 4y plus 30. And the measure of angle 7 is 7y plus 6. 7 7y plus 6. And not to confuse you, 7y plus 6 is the measure of angle 7. It's not 7y plus 6 equals 7. The measure of angle 7 is 7y plus 6. Now let's look at angles 3 and 7 and see if there's any sort of relationship. 3 and 7 are inside of the parallel lines. These two angles are interior angles. 3 and 7 are on opposite sides of the transversal. So these two angles are congruent to each other by the alternate interior angles. So the measure of angle 3 equals the measure of angle 7. And by the way, this is in the language of algebra, and this is in the language of geometry. So the measure of angle 3 is equal to the measure of angle 7. So I can go ahead and substitute. I'm going to write 4y plus 30, which is equal to 7y plus 6. I can go ahead and subtract both sides by 4y, so I have 30 equals 3y plus 6. And then I'm going to subtract both sides by 6 so I can get 3y by itself. And that's going to give me 24 equals 3y. So y equals 8. And that's your answer for B. 3a. If the measure of angle 2 is 4x plus 7 and the measure of angle 7 is 5x minus 13, find x. So we have a new diagram and we can label our figure. The measure of angle 2 is 4x plus 7 and the measure of angle 7 is 5x minus 13. So look at these two angles. We have angle 7 and angle 2. These two angles are outside of the parallel lines, so they are exterior angles. And these two angles are on the opposite sides of the transversal, so they are alternate. So I can say that angle 2 is congruent to angle 7 by the alternate exterior angles theorem. And in the language of algebra, I'll say measure angle 2 is equal to measure angle 7. This is in the language of geometry. This is in the language of algebra. So now we're going to apply substitution. We know that the measure of angle 2 is 4x plus 7, and the measure of angle 7 is 5x minus 13. So all I'm doing is I'm setting these angles equal to each other, and I'm going to apply my algebra. So we have 4x plus 7 equals 5x minus 13. I'm going to subtract both sides by 4x. So I have 7 equals x minus 13. And then I'm going to add both sides by 13 to get x by itself. So x equals 20. And that's my answer. Again, like the previous problems, all I'm doing is finding the variable that I need.